Have you ever heard about some absolutely mind-blowing AI breakthrough, something that sounds like it's straight out of a movie, but then you just never hear about it again? It's like seeing a ghost, right? This spectacular thing appears and then vanishes without a trace. Well, it turns out that's not just a feeling. It's a massive, massive challenge in the world of AI today.
Just think about that for a second. What if a cure for a disease, or a new source of clean energy, or some revolutionary algorithm worked perfectly, but only one time, for one person, in one lab? The whole foundation of science would crumble. I mean, science is all about verifying, testing, and building on the work of others.
And this idea, it has a name: reproducibility. The best way to get it is to think of any science experiment like a recipe for a cake. Reproducibility is just the simple rule that says, if I give you my exact recipe, every single ingredient, every measurement, the oven temp, the baking time, the whole shebang, you should be able to bake the exact same cake. This isn't just a nice idea, it's the absolute cornerstone of the scientific method. It's how we know a discovery is real and not just, a lucky fluke.
Okay, so now let's see how this all plays out in one of the hottest fields on the planet, artificial intelligence. Because this is where that ghost in the machine really starts to show up. And honestly, the scale of the problem is, well, it's pretty shocking.
Okay, get ready for this first number. According to a bunch of different studies, less than a third of published AI research can actually be reproduced. Let that sink in. For every 3 amazing AI papers you read about, 2 of them might just be ghosts, results that nobody else can seem to recreate. And a huge reason why comes down to this next number. A tiny, tiny fraction, we're talking around 5% of AI researchers actually share their complete source code. It's like a world-famous chef publishing a cookbook but deciding to leave out all the key ingredients and measurements. How is anyone supposed to make the dish?
This whole mess, this huge gap between what we hear and what we could actually prove, it has a name. It's called the Replication Crisis. And it's this dawning, pretty scary realization that a lot of what's been published as science might not hold up.
But here's the twist. This isn't just an AI problem, not by a long shot. The replication crisis has been sending shockwaves through all sorts of scientific fields for more than a decade now, forcing everyone to ask some really hard questions about how we do science.
The alarm bells really started ringing back in the early 2010s. You had these famous psychology studies, like one that said just thinking about old people could make you walk slower, that just couldn't be replicated. Then a paper came out that seemed to prove ESP using totally standard methods, which, as you can imagine, freaked a lot of scientists out. But the real bombshell dropped in 2012, when the biotech company Amgen announced it could only reproduce 6 out of 53 landmark cancer studies. 6.
And when you look at the data, it's just wild how widespread this is. In social psychology, some big replication projects found failure rates of around 75%. That Amgen study in cancer research, that's an 89% failure rate. And in economics, major projects have found that over 60% of studies couldn't be reliably replicated. This is not one field's little problem, it's a systemic, science-wide challenge.
Okay, so let's zoom back in on AI. Knowing that this is a bigger problem, what is it about AI's recipes that makes them so uniquely hard to follow? Why are the results so often delicate and just gone in a flash?
Well, there are a bunch of culprits. First, a lot of AI algorithms have randomness literally built into them. They need it to learn. Second, the kitchen hardware really matters. The exact same code can give you different results depending on the computer chip you use. Third, software versions are a nightmare. A model built in one version of a tool can completely break in the next. Then you've got what we call hidden hyperparameters, these tiny little settings the researchers tweaked but forgot to write down. And finally, the big one. A ton of models are trained on private data that just can't be shared.
So what you end up with is this huge gap between the dream and the reality. The ideal scientific recipe tells you everything, and it should work in any kitchen. But the AI reality is that some ingredients are secret, key measurements are missing, and oh yeah, the specific brand of oven and mixer you use can completely change how the cake turns out.
So, I know, that sounds pretty bleak. But the good news is, the AI community is totally aware of this problem and is working hard on solutions. The goal here is to get away from these ghost-like results and start building an AI future that we can actually rely on.
And the solution really breaks down into 2 main parts. First, it's a cultural shift. We need more transparency, more sharing, a movement called open science. And second, we need a really rigorous set of engineering practices known as MLOps, which is short for machine learning operations.
MLOps is basically how you create that perfect, undeniable audit trail for your AI recipe. You start by tracking everything, every single setting for every single experiment. Then, you treat your data and your models just like software code, with version control so you can always go back. Next, you package up the exact software environment, all the libraries, all the drivers, so anyone can recreate it perfectly. And finally, you put your finished models in a central library with all their info clearly labeled. It turns a messy kitchen into a pristine, professional lab.
Look, I get that this might all seem a little abstract, like a problem for scientists in labs to worry about. But the truth is, the stakes of building unreliable, irreproducible AI are incredibly high for all of us. This is where it really hits home. I mean, think about it. Do you want an AI diagnosing a medical condition if its results can't be double-checked by other hospitals? Would you bet your business on a tool that works great one day and then just doesn't the next? When we build on research that can't be replicated, or building our future on a foundation of sand, it also makes it pretty much impossible for us to tell the difference between a real game-changing innovation and just slick marketing.
This quote from Stefan Schmidt it hits the nail on the head. He's saying that replication is what turns a one-time event into actual knowledge. It's the proof that what you found is a real thing, a universal truth, not something that only works for one person in one lab on a rainy Tuesday. It's the very soul of scientific trust. So, I'll leave you with this thought. The pace of AI is thrilling, and the headlines are going to keep coming. But real lasting progress isn't just about that first spark of discovery. It's about building knowledge that's reliable, verifiable, and trustworthy. So the next time you see one of those incredible headlines, I hope the first question that pops into your head is the most important one of all. That's amazing, but is it reproducible? Thanks for listening.